Here's a little bit of code for computing the clustering coefficient, at least one particular way of computing it. Here's our list of flights on our map, with, connection between Chicago and Seattle, etc. And I just have that as a list of pairs. And to create the graph, I start off with an empty graph, and then for each of the pairs that constitute the endpoints of a flight, we make a link between them, like we were doing last time. Then to compute the clustering coefficient for the graph at some node, we list out the neighbors. If there's only one neighbor, it turns out to be very hard to compute the clustering coefficient. So we have to give it some kind of value. I chose 0. It actually kind of matters, but 0 seems like a reasonable choice. Then what we're going to do is we're going to count up the number of links between these neighbor nodes. So we start that off at 0. We loop through all the neighbors, and for each of those, we loop through all the neighbors again, and then we ask, is this pair WU, is there a link between them? And if so, in this case, I'm counting it as a half because I wrote this inefficiently. It's going to do everything twice. So it's going to notice that Seattle and Los Angeles are connected and that Los Angeles and Seattle are connected. So I give it a half each time so that the total number works out. And then I apply the formula. 2 times the number of links divided by length of neighbors times length of neighbors minus 1. So now that we can compute the clustering coefficient for any node V, we can actually loop through all the nodes in the graph, computing the total of their clustering coefficients, and then divide by the number of nodes to get the clustering coefficient for the whole graph. So in this case, it's a little bit above a quarter, which is, pretty clumpy. So there's a fair amount of interconnection between a node's neighbors. From what I've read, social networks will often have clustering coefficients that are in the sort of 0.1, maybe even up to the 0.8 range, whereas grid graphs and chain graphs and ring graphs that we've looked at actually have clustering coefficients of 0.